Take 29 minutes to do sines of 71G.
Because you just like tap it out. Just walk with that H away. Wait, I mean that's
Scientist one said
23.
the pressure would increase as it goes continuously.
I feel like you don't wait. Oh, it's just randomness.
Oh. Is heated.
Wait, the connect.
The particles increase.
Yeah, I think that's just
The lattice
randomness.
pushes
Like,
the container, increasing the pressure.
I mean the thing is what I
So scientist one
and then
has to be
scientist 3
one of the
talked about
things.
random motion.
Means only H and
I
J.
think that's one.
And then scientist two said that the lattice would decrease by reducing the repulsive force, reducing pressure. So J is not right. So H is not right.
All right, guys, let's go over this. 17. Who wants to start it?
D.
Who got it? Okay, why is it D? Whoever said D, tell me why.
Because scientist 2 doesn't, it doesn't say anything about them being the scientist 1 doesn't say anything, and scientist 2 agrees with scientist 1. And
Good.
that means you can cancel out A and C, and then scientist 4 says they don't repel each other, nor do they attract each other, so B cancels out scientist 4.
Good. Yeah, so that should just be D, because this one says there's scientist 4 says there's no attraction force, and then what do scientists 1 and 3 say? That repulsive force, yeah. They say there's a repulsive force, and then where it says somewhere here. Repulsive force, good. And then scientist 2 agrees with scientist 1. So that cancels out scientist 1, 2, and 3. All right, 18. Which scientist would be most likely to predict that heating the air inside a sealed balloon will cause the balloon to decrease in size? Where'd they go?
I said it was G, and I underlined which scientist heating the air, sealed balloon, and decreasing size. I said it was scientist 2 because scientist 2 said that when if a gas in a closed container of fixed volume is heated, the repulsive force between particles will decrease, causing the gas to push less hard against the container.
Okay, good. Whenever you guys do these passages, circle the important line. This one is an important line. Push less hard. And then what is in here? Push harder. And then where is it here? Where is that? Pressure to increase. These are all the exact same thing, but they're differing in either increasing or decreasing. Okay? Then there's one more thing. There's the repulsive force must be circled, and the constant random motion must be circled in all of these. Those are the important distinguishing features of each scientist. All right, 19. And that should be able to easily let you find the answer. So the 18 is in fact G, because they say right here, push less hard against the container. If it's pushing less hard, the pressure is decreasing, so the balloon's going to decrease in size. 19. Let's do it. Amitesh.
Okay. So you underline scientist 3. These particles, will they eventually continue motion? Gas particles 1 and 2.
Okay.
And then go to scientist 3, and it says if the gas particles collide, then the force between the particles will push each other away. So that represents the first one. Answer for B. And then it says, then we'll go in random motion.
I'm sorry, could you repeat that actually?
So the gas particles on the path to collide, then the repulsive force between the particles will push each other into the path.
Okay.
So that represents like the first dimension and answer for B.
And what's your final answer?
B.
Who can also do this one? What's the difference between B and C? Yes.
He says thus gas particles never collide.
Good. You have to read that as you have to underline that as well, because both of these are displaying a repulsive force. Repulsive force means they're going to go in opposite directions. Okay. And also, I don't like how you read the whole sentence. You don't need to do that. Just say it says it. Just circle repulsive force. That's it. Everything needs to be kept concise in these types of passages because there's so much text. So keep it concise and only circle repulsive force. And then also, they'll never collide. That tells us the answer is B. And that is, knowing that they never collide automatically eliminates C and D because they are colliding here. All right, 20. Who can do this? Thank you. Number 20. No, this one. Just graph consistent with which scientists. If you really want to, you don't need to. But the underlining too, it's so very subjective. You can underline whatever you feel is important, but keep it to very few things. Don't be underlining the whole question. All right, so which scientist says that P and T are directly related?
Okay, so if you can look at scientists too, and if it says that like the particles would decrease, you can look at the graph and it says that the pressure is increasing as temperature increases too. So scientists keep that right, and then you can cancel out F and J for that. And since scientists one says that the pressure will increase, but it doesn't talk about temperature increasing in this H could be cancelled out.
You got G as your final answer? Good. One sec. Wait. Yes, that's what I was looking for. Yeah, it's not G. Who can do this one? Megan.
Well, 3 and 4 do say that if the temperature increases, so does the pressure, but so does scientist 1, because it says, like, if a closed container is fixed and the volume is heated, and then at the closer to the end of it, it says thus increases the pressure.
Good. The easiest way to do this is the last sentence of each passage tells us the answer. This one pushes less harder. This one, pressure increases. And this one, he's agreeing with scientist 3. So who's the only one that says as temperature is heated, it pushes less hard? Scientist 2. Everyone else except him. So it's 1, 3, and 4, so the right answer is H. 21. Venkat, how did you get C?
Well, you have to underline things for contains 5 and then complete contains and then the temperature of the gas in each tank is 25 degrees Celsius and the same volume and then scientist 4.
Okay.
And the pressure is greater. It would be good.
Mm-hmm.
I got B because since there's more helium taking up the space and it's heated up, it will move around.
Okay. Is there a specific line that tells you that answer? Did anyone get a specific line for this one, Magna?
It's kind of in scientist 3's actually, though. Because in the bottom it says the number of particles colliding with the walls of the container will increase. The only thing that scientists 4 differs from scientist 3 is that the gas particles can collide with each other. So,
Yeah, that's basically it. But this one too, it's kind of obscure. You kind of have to go off what you learn in chem. There really is no specific line that tells us there's a direct relationship between the number of the pressure is going to increase as the number of wall strikes. But yeah, it's going to be C. 22. Constant volume and temperature, no motion. Who says that? Magna.
scientist 1 actually says it. He says if a gas is released into the evacuated container, the particles in the lattice will move apart from each other until the gas completely fills the container, then stops moving.
Did anyone else get any other different answer? You're very close. But who agrees with scientist 1? 2. Good. So, and does he differ on that? No. So scientists 1 and 2 both agree with it, right? Because look, right here it says, thus the particles can move only if the size of the container changes. And what is the question asking? Unless if it's kept at a constant volume and temperature, it'll have no motion. Well, scientist 1 says it's only going to move if we change its size. So hence it has to be G. Because if both of those are kept constant, it's going to have no motion if we don't change the size. All right. 23. Who can tell me what the kinetic theory of gases is? That sounds very obscure. So what is the one gas law you kind of learn? Very basic chem. Think, relating to this experiment, what would I need to know about 23?
Is it like related to kinetic molecular theory?
I have no idea what that is.
Okay.
Literally none. But kinetic, let me look that up. But this one, you don't even need to know the exact definitions of these. Just know, what do you vaguely think the law is that relating to this experiment? You learned something. Not necessarily.
So like random motion.
Good. Random motion.
That's what
That
it's the
is?
same.
Okay. Yeah, then it's that one. But it's constant random motion. So is that the same thing as kinetic theory of gases? Okay. I'll look that up. But yeah, if they sound similar, they probably are the same thing. But all that means is there's constant random motion. So what should knowing that, what should the answer of this one be? Yes, 4. It's 4. Because, what does scientist 4 say? Let's see, where is it? It's in this one. Right here. Constant random motion. That's the line I was looking for, right there. When it says that, that's the exact definition of the kinetic theory of gases. And also, what Kritika was saying, they're basically asking which one goes with the laws of chemistry, which it's all gases are elastic, which means that no energy is transferred once they meet. They just bounce off each other. An elastic reaction is when the energy is transferred from one thing to the other. All right, let's go on. All right, I'm gonna just do this one quickly for us because we're running out of time. Let's go right to the questions. So this one, I'm gonna underline study 1. I'm underlining study 1, 200, and BRO3. So I'm going to go to study 1, 200, and they want to know, as contact increased, BRO3 did what? So for 200, which is my open circle, as the contact time's increasing, what's happened to BRO3? It's increasing as well. So that there's a direct proportion. So it increased only. 25. 25. Suppose that study 1, a 1 liter sample having initial BR of 300 and the same pH had also been tested. At a contact time of 15 minutes, the BRO3 for this would have been what? Okay, so we're at 350 at 15 minutes and study 1. So whenever you do this on your ACT, you got to flip pages. So you need to memorize numbers and study. So I'm looking for study 1, 350, and 15. So I'm going to go to study 1, 350 at 15. So 15 is right here. And at 350, that's in between 200, because my two samples are 200 and 500. So it's somewhere in between there. So that's somewhere in between 50 and 20. And that's it. That should be my answer. Which one's between 50 and 20? It's C. All right, next one, 26. According to the results of studies 1 through 3, from 5 until 30 minutes, how often was the small volume of water removed from each container for analysis? What is this basically asking? When is my data? What are my data points? What is the interval for the data points? So the easiest way to do this is look at the dots. There's one there and there's one there. What's the difference between those two? Actually, you cannot look at the first few. Look at the majority of it though. What interval are they tested at? The majority are at 5, but I just realized, look at the first 3. They're at 2.5 minutes. But regardless of that, the answer is 5 minutes because the majority of them are every 5.
The question also says from 5 minutes to 30 minutes.
Oh, it did? Okay, that clarifies it then. Good. Because I was like, wait, that doesn't make sense. All right, good catch. Yeah, so it does say from 5 minutes, so we don't even need to look at the beginning part. So we're only looking at from 5 to 30, which, just look at the data points. It's every 5 minutes. Every dot is found every 5 minutes. And they like to ask that question because that was on my actual ACT. They asked that. According to the results of study 3, for contact times after 0 minutes, how did the addition of ammonia affect BRO3? Okay, study 3, adding ammonia. That's all I'm looking at. For study 3, adding ammonia did what? So adding ammonia is a darker one? Well, it decreased. That's all I need to know. So what's my answer? It should be A because the BRO3 was less with ammonia added. And that's what this graph shows. After we added BRO3, after we added ammonia, the curve was significantly lower than when no ammonia was there. Hence it's A. 28. What variable had the same value for all the samples in study 1, but did not have the same value in study 2? So it's different in study 2, but it's the same in study 1. What's the easiest way to find this answer? Nope. Nope, not the axes. The easiest way. Yes, the key. But for which one? Study 1 or study 2? Good, study 2. So what's changing in study 2? It says right here. Yep, pH. Look at the key. That's your answer. Because the pH needs to be the exact same in study 1. If not, that's not a real experiment. Because an experiment can only change one thing. If you have two things changing, that's a confounding variable. So in this one, they're changing the concentration. So the pH must be the same. If you really wanted to, you could read this and you'd find that the pH is kept constant for all 3 samples. But they said that something's changing in study 2. But it's the same in study 1. Well, we know it's pH. All right, 29. Based on the results of study 2, was more BrO3 produced during ozonation of the acidic or basic? Okay, this one you need to, this is a prior knowledge question. Let's go over pH really quickly. You have your pH scale. This is 7, 14, 0. Who can tell me what this part is? Good. What is 7? Neutral, good. And then 14? Basic, perfect. That's all you need to know. All right, so study 2 was more BrO3 produced in acidic or basic? So I'm going to go to study 2. One was more BrO3 produced. Well, it's for the topmost curve. And what is that? It's the blank circle. So that is pH of 6.4. 6.4 is what? Or 8.4. My bad. No, 8.4. Yep, that's not acidic. Who said acidic? Oh, basic? Okay. Yeah, that is basic. So that automatically eliminates. Remember, these types of questions, vertically analyze it. There's only one or two things that are different. Look at the second word in each one. The acidic, and the basic, and basic. So which answer choices can I automatically eliminate? A and B are out. I'm left with B and C. C and D, I mean. So let's find what's different. Yep, it's this last part right here. So what should the right answer be? D. Because 8.4 was greater than 6.4. The BrO3 concentrations. See how easy this one was? Alright, let's go on to this one. Alright, who wants to start with number 30? Ben Kent, number 30.
We find 5 times 10 to the 9th power, and then we go down the line where you can go down and you'll see 0.6.
Good. I circled 5 times 10 to the 8th. It's 5 times 10 to the 9th, which is right up here. And if you draw that line down, it's 0.6. All right, next one. So that answer is J. All right, 31. Who can do this one? This passage was really hard. It takes, you have to think critically to answer this whole passage, basically. Krishna.
So I underline the B equals NV and the bigger B. So if V equals NV, that means both values are the same, and then the axis for 32 is V minus NV. So if both of the values are the same, then one value minus the other would be 0. And if you leave a 0 on the line, it's 10.
Perfect. All right. Rohit, I want you to explain this question back to me. Thank you. Explain this question back to me. Lauren.
What you just said.
Explain it back to me, yeah.
31. Okay, so V equals MV means that they're like equal. They have the same value. And then when you look, it starts at 0. And then when you look at 0, like where it is, it's at 10. You see?
Perfect. All right. Thank you, Rohit. There's no excuse why you guys should not have been able to explain that, okay? All right. 32. Based on, if anyone has a question on 31, ask me, because that one's a confusing one. 32. Who can do this one? Kritika.
So analyzing tables into power output of visible light, greatest and least force cycles. So it was SC4, but I don't remember how it
Okay. Explain how you got SC4 first. Okay. Who wants to help her out? Brianna. Alright, Kritika and Brianna, let's try working this out then, okay? So, based on tables 1 and 2, That means I need to use sources of information from both of these. The power output, greatest, for which 4 clusters. So table 1, power output, greatest. That's all I'm looking for. So let's look at tables 1 and 2. Let's put them side by side right here. All right. They said to look at tables 1 and 2, and they want to know which cluster is greatest. Well, my answer choices only gave me SCs, so I must be looking at some row. Okay? But what value in this row am I looking for? Good. And why is that? Because in table 2, it's relating MV and power output. And they want to know, that the only thing they said was tables 1 and 2, greatest power output, and clusters. So tables 1 and 2, power output greatest. Okay, well, if I want my power output to be the greatest, which one is that? 3.2 times 10 to the 26th or to the 10th, 29? Look at the 29. Good, that's a higher power. So I must be looking for my lowest MV, the most negative one. Okay, well, let's find MVs in my clusters. It's this column, right? In this column, which one has the lowest MV? Yes. So it should be SC2. Does that make sense? All right. Hence the answer should be G. All right, 33. Rohit.
I got C for this one.
Okay.
And the line table 1. MD, SC1. I got this was, it's asking what is MD. So I looked at table 1 and went to SC1 row. And then I saw MD equals 1.5. And then MD minus MD is 0. So it should be 1.5 minus 1.5, which is 0.
Good. If you think more by equations, look at this. MB minus MV equals 0. I know the value of, what is it? MB right there. MB minus the value of it is 1.5 equals 0. MB, move this to the other side, equals 1.5. That's your answer. Okay, that is C. 34. Megano.
Okay, so I underline MB minus MB increases, and then the surface temperature decreases, and based on table 1, and then lower, and then for SC3 or the SC4. And I said J, because it said as MB minus MB increases, so then I went to the MB minus MB table 1, and the fourth one has 0.30, while the third one has 0.15. So the higher the MB minus MB, the lower the temperature. So,
Good. So which one should it be?
J.
Good. Does that make sense, everyone? 35. All right, let's go over this one. Who wants to start with 35? How many of you guys finished this whole test? Okay, figured it. Let's take another 2 minutes and finish it. Guys, this is where in your homework, you need to be cutting your time down short. That is the only way you're going to get faster at taking this test, and that's the only way you're going to get a good score. So take 2 minutes and finish the rest of it out. All right, let's go to this. $35. Who can do this one? Lauren.
So if you look at R, it's increasing for all four, and then
Tell me what I'm looking for first. My question.
Oh, study one.
Okay.
V equal V is 9,000, and then R.
Okay.
And then you look at study one, and you look at the table for that, and for all four, V and R is increasing. So if you increase V, R has to increase.
Good.
And the only one that's increased for R is D.
Perfect. So you just look at this overall pattern as V is increasing from 3 to 7. Your R is increasing from 0.056 to 0.140. So if 9,000 is somewhere over here, you must have a higher value somewhere there. So the highest value that's greater than 0.140 is 0.168. All right, 36. Here they go.
So I underline trial 6, malfunction, two values of R, 0.047 meters and 0.070 meter, and electrical charges, and best explain this result. I think the answer is H, because when the Q was plus 3, it's we got 0.047, and when it was plus 2, it was 0.07. So the only reasonable explanation would be if there was a focus on it, and that's why you got like two different values.
Good. So if you look right here, you'll find your answer. At 3, it was 0.047. At 4, it was 0.035. And that's exactly what they said right here. It was 0.047, and it was I circled the wrong thing. Yep. Circle the top two, 2 and 3. It should be those two, because you're looking for 0.07 to 0.47. And that's at sometimes it was 3, and at sometimes it was 2. 37. Who can explain to me what magnitude is and what direction is? This is physics. Who can do this? Krishna.
Magnitude, speed, and direction.
Good. Yeah, the easiest way to do this is magnitude does not show. This one shows your plus and minus. This one does not. This one is your absolute value of whatever you're dealing with. Okay? So direction means I'm going positive 8 meters. That means I'm going ahead. Magnitude just means I'm going 8 meters. Does that make sense to everyone? Direction tells me if I'm going forward or backwards. Magnitude just tells me how much I'm going by. Doesn't tell me if I'm going forward or backwards. Knowing that, what is 37? How'd you get B?
From ions source to hole, the ion is moving in a straight line, so the direction is not changing. And so because the direction is not changing, C and D, you can't do those. And then from the formula plate to the detector, the direction is changing. And so it has to be B.
Perfect. So you can see from here, from this starting point and to this end point, it's going in the same direction, which is forward. However, from the exit plate, the metal plate, to the detector, it is looping forward and then backwards. So the direction is changing, which is why it's B. All right, 38. Venkat, 38. Meghna.
Okay, so I was thinking it was F because I was looking at the three studies and then I was in each one they have R and they have one of the letters, so V, Q, and B. And so R and B, when B increases, R increases, so that means that they both are directional. But then in Q and R, as Q increases, R decreases, and in table 3, as B increases, R decreases, so that means Q and B both are inversely
Good. Yeah, what does directly and indirectly mean? Who can tell me? Lauren, tell me what those two mean.
Directly proportional is like
As what? Who can tell me what directly proportional and indirectly mean? Brianna.
Well, if they're directly, it means like they're both going to be going like up or down. If they're inversely, then one's going to go up and one's going to go down.
Good. Lauren, what relationship is this graph? Those are two axes, that's the line. Is that direct or indirect? Just Lauren. So how do we know it's direct? What did Brianna say was the definition of direct? As one goes up, the other goes up. So if this one is increasing from here to here, what is this one doing? Well, it's increasing as well from there to there. Because look, as we're going higher on the graph, we're going higher on both axes. Does that make sense? Okay. And then what is this relationship? This is a indirect, because as I'm going higher on this axis, I'm going lower on this one. Okay? So, to find our direct and indirect relationships, as V is increasing from 3 to 7, what is R doing? Increasing. So, the easiest way to do this, V increases, R increases. Q, as Q increases, what does R do? Decrease. Okay, Q goes up, R goes down. B increases, what happens to R? Decrease. What's the only one that's directly? It's your V. That's your answer. That's it. That's all you need to do. V is directly. Don't even bother with inversely. I've been saying indirectly, it's inversely. My bad. I just realized that. 39. We can do this. Quickly go. 39. Lauren, 39. Brianna, 39. Alright, you guys need to take a minute and figure 39 and 40 out. Alright, let's go over it. 39, did you guys figure it out? Okay, give it a shot.
Okay, so I underlined trial 7, new trial B equal 0.12 T instead of 0.1, and then results of study 2 and 3 are equal 7. So if you look at study 3, where B is 0.12, that's at trial 10, it's at R equals 0.117. So if that's already your baseline, it would have to be greater than 0.07.
No. Okay, so whenever you do this, whenever they give you two charts to look, they're 90% asking you to look at a trend. Okay, so when they lower it from 0.12 to when they increase it from 0.1 to 0.12, they're looking. Can you tell the trend? What is the trend from here? As I'm increasing B, what's happening to R? It's decreasing. Yes. So my right answer would need to be if I'm decreasing R because I'm going from 0.1 to 0.12, it's got to be less than 0.035. Does that make sense? Because look, my B went from B initially was what was it? 0.1. But B final is now 0.12. So if my B is now 0.12, so I increased B. That's all you need to know. You don't need to know values. Just know you increased B. So look at this chart right here. Increasing B lowers R. Hence, my R needs to be lower than that. That's all you need to look at. You don't need to know specific values. You just need to know we increased our B, which we know from here, increasing our B lowers R, and it's got to be lower than 0.035 because that's trial 7. Does that make sense to everyone? All right, 40. Meghna. Who wants to do 40? Amitesh.
So from the you underline figure 1, and then middle plate. From the hole of the middle plate, the time to enter the detector. Yeah. And so you go to figure 1, and the path from the middle plate to the detector is half a circle, and since the perimeter of the circle is 2 pi r, and half of it would be 2 pi r by 2. So
Good.
pi r, so it would be C.
You just need to know this formula. Multiply by half C equals pi r. That's your answer. All right, we're going to go on to English. Give me a sec. You pass that to Zach. Actually, give me that packet back, because there are 2 in there. Can you separate those 2? Thank you. Yeah. Alright, you can head out, watch the video. I want this Scantron done, because I'm going to check it in for you then, okay? Take the Scantron with you.
Alright.
Or right here. Yeah, that's fine. Don't start. Actually, you can finish the first passage probably. Yeah, actually, you have to leave your mouse here. All right, does everyone have a copy? Amitesh, your parents are out, so you can stay here till like 9, okay? Alright, let's pass. Take these, pass. Take one and pass it down. Alright, you guys have 21 minutes for 73C reading English, and you guys can start.